Okay, how hash map stores our internal, how it works? How a hash map internally works? This is the one of the famous interview question. We can easily explain if you understand this. See that. So basically, when you create a map string, key and value and map name equal to new hash map, you are creating object for hash map. Once you create object for hash map, and object, obviously there is a 16 buckets will be so created in the map internally. So JVM creates so 16 buckets in the map heap area, right? In the heap. So only 16 buckets? Yes. First time it will create a 16 buckets. If your hash map reaches 75% of its capacity, then it doubles the existing capacity. So that's the load factor is a main important here. So linked list. So you need to understand one more concept here, linked list. See, linked list is going to store the data in the form of buckets. Bucket is nothing but a linked list. So this is the one bucket. In linked list, one node, this node is pointing to other node. That is the linked list structure. So if this element, you can insert here also, you can delete, you can anything you can do, even here also, both sides also you can delete. So you can add the node in both front and last also. That's a linked list, one of the important concept we need to know. See, every bucket is having multiple nodes. Each node, this is the one node, this is the one node, and this is another node. Like that, your linked list will grow. If the key value pair get this entry, this bucket, right? So, like when you are choosing different teams, if you are following multiple people in the same team, all will go like this. Each person will go like this. The bucket, for example, A team will go to first, B team will go to here, C. So if you choose like IPL matches, different teams are there, right? So each team has a different persons. Each person will store in this node, one person here, one person here, one person here. So like this, your bucket will have multiple nodes as a linked list. You keep on adding a new person, it will add another node here in the same bucket. If bucket index is same for all the members, and your linked list will grow, but same bucket only. But how do you know which bucket it will go on? So you are going to find out that. You are going to find out which bucket that is. So how to find out? Let's see, first understand hash map means once you create a map object, it will create a 16 buckets. First you should know that. A bucket generally carries the water, right? Same way here, it carries the data here. So each bucket again is going to have multiple nodes, linked list. Basically a linked list. It is going to have linked list. So JVM takes the put method. So when you want to enter key value pair, and first step is when you call map.put, key and value, both are strings. This is the key and this is the value. The first what it will do, it will take the key and find out hash code value of that key. So what it does, hash code value of this, it will find out. That's the first step. When you call the put method, first it will find where to insert. We don't know, right? 16 buckets are there. In 16 bucket, where to insert? How do you know that? For that, first it will find out the hash code of this key. That's the first step. The second step, you will get the hash code, right? Some hash code means the memory address. Hash code. Based on that hash code, it will find the bucket index. Okay, which bucket it has to go? The bucket index, it will fetch. So that's the hash code, ampersand, length -1 they will do. Then you will get a bucket index. The bucket index, suppose 12. We have a 16, right? 0 to 15. So 12th bucket, you got it. 12th index. So in the 12th index, so this key value pair will go and store there. So this is how it will store. So internal structure of hash map is first we will call the bucket index, and you got that 12, right? And it will go and store in the linked list node. So this key and value will go store in the one node in this bucket, 12th bucket, as a one node. So this node as a reference of pointer to the next node. Okay, that is done. First one. Let's take one more key value pair. Enter one more key value pair. Map.put LDB. Now what will happen again? Again also, first step is calculate the hash code. Then find out the index, bucket index. Suppose this got a eighth bucket. Already one entry we entered in the 12th bucket. Now we got a 8th bucket index. Now, so this value LD and B will store as another one fresh node, because previously no node present in the 8th index, right? So one node will add. In that node, the key value pair will store here. Now 8th and 12th buckets are filled with one node. Now let's take one more data set that teaches the hash collision. Please understand, this is very important. Hash collision.
Ramesh, sorry to disturb there. Ramesh, there, how that index was getting generated?
It's internally this one. This is the formulas will be there internally based on this hash code. This ampersand is there, right? The ampersand will calculate that.
Okay, I mean that is not decided by randomly. It will be calculated by system itself.
Yeah, system itself.
Okay.
The ampersand, not double ampersand. It's
Okay.
ampersand. So that ampersand will convert this hash code and the length -1, total length -1, and you will get the index.
Okay.
That's the formula. Hash code ampersand length -1 is the formula to calculate the index.
Okay.
So every time these two steps will be repeated when you are using a put method.
Okay.
First it will decide, okay, which bucket it has to go will be decided with these two steps.
Yeah, okay, Ramesh.
Okay. Now let's understand hash collision. The bucket is having already two nodes, right? So the bucket is having already so the entire map is having two nodes having the data. And if you enter one more data, suppose this entry is going to the same bucket where the previous first data is there, 12th bucket. This also got the 12th bucket. Now what is the procedure? Already you have one data, right? In the 12th bucket index, you have FBA is there. Now one more entry got the same bucket. Now what will happen here? So what do you call that? So this entry also got the same bucket already previously one entry is there, then what you call that is hash collision. The bucket is having already one node, and again JVM tries to place one more node in the same bucket. That is called hash collision. What is hash collision? The bucket is having one node already, and again JVM tries to place one more node in the same bucket. That is called hash collision. So this is the important point they will ask. What is mean by hash collision? Is this clear? JVM checks if same key is present in the bucket or not using equals method. I told you, you're going to use equals method. JVM checks if same key is present in the bucket or not using equals method. If same key is present, then JVM will update the existing key with a new value. Please catch all these points. If, for example, already existing 12th bucket, you have, right, one value. This value of VA. Second entry also have the same key. Then how do you check that this key and new entry key is same or not? That is with the equals method. You will compare. So new key equals the existing key in the 12th bucket. Both will be compared. Check if two objects are equal or not. Now these are equal or no?
Both are not equal.
Both are not equal, right? So those are not equal. Now what will happen is, now this entry will go and store as a one more node to the existing node. If those are same, this value will update. No other node will be added. But if these two are not same, right? This key and existing key is not same. Now, obviously, it will happen. One more node will add here in the same bucket. So the linked list is growing now like that. If same, what will happen? This is the question they will ask sometimes in the map. Suppose already in one bucket you have the key value pair same, and second also same key value pair, but value is updated, value is new value. But what will happen? It will add as a new entry, or it will do? So what is the answer you have to tell? It will update the keys are same. It will update the value with a new value. Suppose, so this is also FB, but C value. Before A is there. Now what will happen? Same key means now this will update with the C. A will replace with the C. If it is same, now it's not same. So another node will add in the same bucket. Clear? So this is the what is happening. If the existing key is not equal to new one, then new data will be added to the same linked list as a second node. Now you can observe the linked list is growing. So if equal, this will update. If not equal, a new node is adding. So that's how linked list will work. The entire summary is here. So when you call a put method, first hash code will be called on the key, then get the bucket index using hash code and length -1. Then if the hash collision occurs, this will go this side. If hash collision is not there, simply add to the linked list as a first node. if no hash collision means. Hash collision means so already one element already stored there. No hash collision means simply that value will go store in the say one bucket as a one node. And if hash collision occurred, already one element is present in that bucket. So then what will happen? You will call equals method will be called immediately. So already existing key and new key will be compared. If both are same, if this is written as true, add to the linked list by replacing the existing node with a new value. If not equal, add the second node in the same bucket. So this is the entire summary of what we discussed till now. So that is the how hash map works and how you will insert how it will go and store in the memory. So when you are searching with linked list how it will search, right? The element. Suppose linked list will search one by one node, and then so it will take more time. First, you want item 3, what it will happen? Item 1 compared with this one, and item 2 compared with item 3. No, item 3 compared with item 3. So like that it will compare. See, you want item 3, right? You want to find out item 3. See how it will compare. Each node it will compare. So that takes more time. That's the drawback of linked list. Searching takes more time. How will get key value in the hash map? So we saw how put map will work, but how get key value in the hash map is again same. When you call map.get EA, first the key will, based on the key, it will find out the hash code of that key, then find the bucket index, go to bucket index 12, get the key value pair. So, and now, so this is the thing. For example, so first it will fetch where this key is present. First it will search here in this node. If it is not there, it will go to second node in the same bucket index. So you are getting a bucket index first, right? First with the key, you are getting hash code, then bucket index. Then obviously it will go to that bucket only, it will search in that linked list. So that's the how this get method will work out. Okay, any questions on this? So here are some of the examples I have given. Please go through this. Yeah.
So in how many nodes can JVM create in one bucket?
One node only. First one time, one node only. First time. And when you keep on adding, if you're getting the same bucket, right? Same bucket, it keep on adding. If not same bucket, it will go to other bucket, one node only, first node only. Like that, only hash collision time only your linked list will grow. If hash collision is not happened, there is no linked list
Go
growing.
for another bucket. Okay.
Yeah. Another bucket.
Yeah, I got it.
Yeah. So that's how it will store the data.
So hash collision will take care of, JVM will take care of automatically, right? We need to write equals code internally.
No need, nothing. Okay. You don't need to do anything. I'm just telling how it will store. Internally, it will calculate all this bucket index, everything, hash code, bucket index. It will automatically internally calls.
Thank you.
So please go through this. These questions, some of the interview questions I have added, and try to answer, these some of the questions I have added many here. So then another important interview question is difference between hash map and hash table. A lot of theory will be there here, and also they will ask programs also. But yeah, we need to read multiple times to remember this before going for interviews. Please read the difference between hash map and hash table and array list and linked list. These are the common questions. List and set. So these are the regularly asked questions, and so make sure you're thorough with at least 3-4 points, and that really helps you to get some uh, good benefit in the interview. Okay, so what is this hash table and hash map? Both are store the data in the key value fair format. Both are using hashing technique to store the keys, but there are differences are there. Hash map is non-synchronized. It is not thread safe. Can't be shared between many threads without proper synchronization code. Hash table is synchronized. It is a thread safe, can be shared with many threads. Hash map allows one null key and multiple null values. Hash table doesn't allow any null key or value. Hash map is a new class introduced in JDK 1.2. Hash table is a legacy class. From the beginning, it is there. Hash map is fast. Hash table is slow. We can make hash maps synchronized by calling below code like map m equal to collections. Collection is different. Collections is different. Don't confuse. Collection is an interface. Collections is a utility class. Okay, I'll discuss this collection and collections difference also. Collections dot synchronized map. All this is the class. This class is having all static methods. So you know static methods how to call, right? Class name dot static method. But this method returns a map. The return type method again. So this method returns a map type. Map m equal to collections class dot synchronized map, hash map. So hash table is by default synchronized. You don't need to, again, unsynchronization cannot be done. So that's the one thing. Hash map is traversed by iterator. Hash table is traversed by enumerator and iterator. Iterator in hash map is fail fast. Enumerator in hash table is not fail fast. Hash map inherits the abstract map class. Hash table inherits the dictionary class. So not required all of them, at least a few of them land here, which is important points. Just try to so speak out, then it will help you there. How to sort the collections? So there are many ways you can sort, many type of objects you can sort, like a string objects, wrapper class objects, user defined class objects, you can sort generally. And I mentioned class collections class is a utility class which has all the static methods for so different purposes. Every method is a different so purpose they created in the collections class. So same way to sort the elements, they provided the collections. So sort method is there. So collections dot sort, you can sort the list of elements, and that's the one way. Another one is there is a Java comparable and comparator. Two interfaces are there. This is the very important interview question. What is the difference between comparable and comparator? So let's go directly. The differences we'll discuss. So no need of all the theory part. So comparable provides a single sorting sequence. Based on one element, you can sort it. Suppose you have a student class. In the student, you have ID, name, and price, right? So you want to sort based on the ID, all the elements will be sorted based on the ID. Any one element based, you can sort it. That's the comparable single sorting sequence only it provides. Comparator, you can sort the elements, multiple sorting sequences can be achieved. We can sort the collection on the basis of multiple elements such as ID, name, price. So multiple elements based also you can sort here. That's the main difference between comparable and comparator. So comparable affects the original class, the actual class is modified. Comparator doesn't affect the original class, so the actual class is not modified here. You have to create your own comparators, own comparator class. That comparator you will pass it to collections.sort method. Here, collections.sort method, you have to provide the list collection and which comparator. So you can write your own comparator class, then you can pass it here. So that will be sorted. And so comparable provides the compare to method to sort the elements. Comparator provides compare method to sort the elements. So comparable is present in java.lang package. Comparator is present in java.util package. So we can sort the list of elements of comparable type, just calling collections.sort list. We can sort the list of elements of comparator type by collections.sort list, and you have to pass the comparator type. That's the main difference between comparable and comparator. So there is a lot of differences. I'm just providing here one by one. Let's finish these differences. What is the difference between ArrayList and vector? And you know, ArrayList and vector both implements the list interface, right? And ArrayList and vector both implements list interface and maintains the insertion order, right? Both maintains the insertion order only. But there are differences. ArrayList is non-synchronized, vector is synchronized. ArrayList increments the 50% of current array size if the number of elements exceeds the capacity. Vector increments 100%, means it doubles the array size if the total number of elements exceeds its current capacity. ArrayList is not a legacy class. It is introduced in JDK 1.2. Vector is a legacy class, like a hash table. Vector also legacy class. ArrayList is fast because it is non-synchronized. Vector is slow because it is synchronized. So in multi-threading environment, it holds the other threads in a runnable or non-runnable state until current thread releases the lock of the object. So just tell a few points. It is fast and it is slow because of synchronized and non-synchronized concept. ArrayList uses the iterator interface to traverse the elements. A vector can use iterator interface or enumeration interface to traverse the elements. Both you can use. So that's the difference between ArrayList and vector. Yeah, we got the difference between collection and collections. So what is the difference between collection and collections? Collection is an interface and collections is a utility class. So class in the collection. Collection is a base interface. Collections is a utility class in Java. Maybe you can take this as a 1 point only. 2 points not required here. Collection defines methods that are used for data structures that contains the objects. But collections defines the methods that are used for operations like accessing, finding on the collection. These are abstract methods. So if you want to perform different operations on the data structures, collection, you will use a collections method. but collection has a abstract methods. That's interface, right? That's why. So collection has only abstract methods, but collections consist of only static methods. So these are the main differences, or at least you can tell 2 points. One is interface, one is a utility class. And collection methods are used to just perform some operation like accessing, sorting, finding, such kind of things you can do with the collections class. Collection methods are abstract methods. You can just insert the elements, all the such kind of operations you can perform with the collection interface. Then what is the difference between arrays and collection? So as you know, this is another common question. Arrays are fixed in size, but collections are dynamic in size. First point. With respect to memory, arrays are not good to use, but with respect to memory, collections are better to use. With respect to performance, arrays are better. With respect to performance, collections are not good to use. Arrays can hold only homogeneous elements, one type of data, right? That's a homogeneous. But collections can hold both homogeneous and heterogeneous elements. Arrays don't have ready-made methods, as I mentioned yesterday also. They don't have any ready-made methods, but collections have ready-made methods, and which makes collections more easier, user-friendly to access the elements and insert the elements. A lot of operations you can perform with the methods. Arrays can hold both primitives and wrapper objects, but collections can hold only objects. So class cast exception occurs in collection, but not in arrays. And we have iterators for going through the collection, but we don't have any iterators in the arrays. So Java returns arrays rather than collection in most of the operations due to performance issues. So these are the some of the points. Please remember, and this is the one of the very, very important interview question. So let's finish this properties class also today. We have 6 minutes. What is properties class and how it will be useful. And the next class we'll write the programs only, then we can close. So what is properties class? When you will use this? So properties class again stores the key and value pair both as a strings only, always. So this class is available in java.util package. It is the subclass of hash table. It can be used to get property value based on the property key. The properties class provides methods to get data from the properties file and store data into the properties file. So what is the purpose of this properties file? So you have a properties file you will create in your project. In the properties file, generally will store key value in the properties file. If you want to get the key value, and you will use this properties class. There is a method, get property method, and set property method is there for setting the value, and get property will get the value based on the key. That purpose you will use this properties class. These are the methods. So properties class methods are load method. It loads the data from the reader object. So load input stream. So it loads the data from the input stream object. So get property string key. It returns the value based on the key. Get property string key, string default value. Again, it returns the value of this specified key. Set property string key, string value. It calls the put method of hash table. We have one more store method. So store method generally uses, it writes the properties of a writer object. So you want to write to the file, you can use first store method, first set property method, then you can write the store. It will store them. So that is the main advantage of properties class methods. We just need only 3 methods. First, how to use these methods. See, these are all non-static methods. See this. If you want to use this method, first step is create object for properties class. Then, so you initiate the file and file input stream or file reader classes. And then that object reference, you load them. So with a properties object dot load and pass that reader object here, or input stream, file input stream or buffered input stream. So you pass here, or file reader, buffer reader, you can pass it here. So just loading all the properties in your program, and then you can get it with a get property method, which property you want. So this is the one of the methods generally we use. We'll write a one method, and that method will get all the properties file data to you. So is it constant? So you can change the values, but key is constant. So that's why if you use in the programs in your classes, you will modify only in the file, not in the code, because you will use only key, right? Even value changes also, it doesn't affect. So that's the main advantage of this properties file. Why do you need to use? That reduces the lot of duplicate code, and also less maintainable, and only one place you will change and it will reflect all the places. That's the advantage of this properties class and their methods. Okay, and streams. Okay, this is the big topic. Streams in the Java 8, they introduced the streams and collections. So already collections are mainly used to store a group of data. Streams are mainly used to perform operations on the group of data. On the collections only, you will perform streams. So collections, you can add or remove elements from the collections, and you cannot add, remove elements from the streams. Collections have to be iterated externally, and streams are iterated internally. Collections can be traversed multiple times. Streams are traversable by once only. Collections are eagerly constructed. Streams are lazily constructed. So collections, list to, set to, map, these are all collections, right? Streams are filtering, mapping, matching, grouping by, all these are streams. Okay, so that's all about collections. So let's plan next class all the programs, map programs, then we can close by one more class. Okay, thank you. Any questions? Please read this